Hi Math, I'm Andy. We know that the derivative of f at x is defined as the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Now this is for any point x, but we have an alternative definition for the derivative as well. And so we're going to kind of use that alternative definition to show you how to find the slope of a tangent line. So let's say we have at a point C. At point C. Now when I say point C, I just mean that's like the x-coordinate of some random point that's on our curve. Well, I can say that f prime of C, meaning the derivative of the function at C, is going to be equal to the limit as x approaches that value C of f of x minus f of C over x minus c. And so we're going to use this definition to help us find the slope of a tangent line at some given point on the function itself. So let's start with a function. Let's say we have the equation y equals x squared plus 4x, and I want to know what is the slope of the tangent line at the point when x is equal to negative 5. So here's our question. And now we have two kind of options that we can use. We can use the definition of the derivative, or we can use this alternative definition. I want to walk you through how to use the alternative definition. So really, if I were to kind of use this as my c value, negative 5, just plugging this in, it's going to look like this. F prime of negative 5 is going to be equal to the limit as x approaches negative 5 of f of x minus f of negative 5 over x minus negative 5. Now notice I still have minus and it's a negative 5. We will switch that into a plus plus. We'll add opposites in just a bit. Now let's kind of show the math behind all of this. So when I see f of x, I'm going to use what f of x is, the actual function. When I see f of negative 5, I'm going to write the function, but I'm going to substitute negative 5 in for those values of x. Then x is x and minus 5 will stay. So kind of rewriting my numerator, the limit as x approaches negative 5 of f of x is x squared plus 4x minus, and then f of negative 5 is going to be negative 5 squared plus 4 times negative 5. So again, what I'm doing is I'm substituting that value of negative 5 into my function, and then down at the bottom, I'm just going to do that add opposite technique and just write plus 5. Now there's some evaluating that I can do. I know that negative 5 squared is positive 25, and I know that 4 times negative 5 is negative 20, and I can combine those like terms. So just writing above this, this is going to be 25 plus negative 20, and 25 plus negative 20 is 5. So in my numerator now, I have this x squared plus 4x. I have that minus, and then we've already done this math, and we end up with a 5. In my denominator, I have x plus 5, and I'm still taking the limit as x approaches negative 5. Now taking limits, one of the easiest ways is to do a direct substitution method, but we notice when we plug in negative 5 for x, we're still getting that 0 in our denominator, and so that isn't what we want. And so we're required to do a little bit more algebraic manipulation to kind of see if we can eliminate that from happening. Now, I do notice that I have this x squared plus 4x minus 5, and I notice that that actually factors into two binomials. One of those factoring techniques, you may have learned the x method, where you kind of, you put the a times c up at the top, you put b at the bottom, and you figure what numbers multiplied to make -5 and add to make -4. And you're right, the numbers are going to be 5 and a -1. Those are going to be my constants of the factors. So my numerator, this limit is still here. The limit as x approaches -5, x squared plus 4x minus 5 factors as x plus 5 and x minus 1 over, and I still have this x plus 5 in my denominator. Now this works out really nice for us because now we have two common factors in my numerator and denominator, and so those are going to cancel each other out. And so my problem really boils down to the limit as x approaches -5 of x minus 1. And this is something that we can use direct substitution for all of a sudden. I end up with -5 minus 1, and I get a -6. So what does this answer really mean, -6? Well, this answer means that on the function x squared plus 4x, so when the function f of x is equal to x squared plus 4x, at x equals -5, the slope of the tangent line is -6. And remember, -6 is a slope, so that kind of means rise over run. So you're going to go down 6 over 1, down 6 over 1. So finding slopes of tangent lines, there's multiple methods. One, you can use the definition of the tangent line, or you can use this alternative method, just starting directly at that value of c.